Hey guys, today we're going to be looking at how to write an equation in slope-intercept form, which is y equals mx plus b, given information in a table. So previously we looked at how to find slope-intercept form from a graph, and we talked about how our y-intercept was the simplest thing to find. Well, with tables, if we're not given it in our table, we kind of have to work like a puzzle and work backwards. So the first thing in tables that I like to solve for is to find my slope, or that change in y over that change in x. And so when I see my table here, I see I'm looking at ticket sales, and it's hours since 4 p.m., and the number of tickets that remaining. So I see each hour, the tickets are decreasing. And so from hour 1 to hour 2, that's an increase of 1 hour, and 3,000 tickets were sold. So every hour, and that pattern continues. Every hour that increases, 3,000 tickets are sold. Until after 5 hours, there are no more tickets. So that tells me that that change in y was that decrease, a decrease in tickets of 3,000 every 1 hour. So my slope was negative 3,000. And what it means is every hour, 3,000 tickets were sold. So now we want to find that y-intercept, which is where it crosses our y-axis. And so on a graph, at any point along the y-axis, the x value is always 0. So in a table, the point for the y-intercept will always be 0, comma, whatever the y value is. And because I don't see 0 in my x table, in the x column of my table, I'm going to work backwards to get to 0. So I want to know how many tickets remained at hour 0. So if I'm going, every time I'm increasing by an hour, then my tickets decrease by 3,000. Then when I'm working backwards, if I'm decreasing by an hour, my tickets will increase by 3,000. So if I was at 12,000 tickets and then I increased by 3,000 tickets, that means that at 0 hours, there were 15,000 tickets, and that is how many we started with. So if our slope was negative 3,000 and our y-intercept was 15,000, that is now enough to write an equation in slope-intercept form. So y will equal m times x, so that rate of change, which is negative 3,000 times x, and then plus the initial value, or the y-intercept, which is that starting amount of 15,000 tickets. And that is our equation. All right, let's look at one more. So now we have car rental, and it tells us the number of miles and then how much they're being charged. And again, our goal is to write an equation in slope-intercept form. So I will need to find my slope and my y-intercept. Slope being that change in y over that change in x, and the y-intercept being where it crosses the y-axis, or that initial value, or when x equals 0. So when x equals 0, we get the y that is the y-intercept. So again, I find it simpler to find the rate of change first. So I see that x increased by 5 miles. So it went from 5 to 10. And then when the miles increased by 5, the amount charged increased by 50 cents. And I see that that pattern continues. So every 5 miles, the cost increased by 50 cents. So for the slope, that change in cost, or that increase of 50 cents for every 5 miles, would be our slope, which I can create an equivalent fraction of, and say I can scale up by 2 to get 1 over 10. So my slope would be 1/10, or as a decimal, 0 and 1/10. And that means that every mile, the charge increases by 10 cents, which is the same as saying every 5 miles it increases by 50 cents. And so the same thinking, now we want to work backwards to say, okay, well, what was the price when we had done 0 miles? So instead of increasing by 5, now we work backwards and we decrease by 5. And so every time I had to increase by 5, I had to increase y by 50 cents. So now that we work backwards, my cost is decreasing by 50 cents. And so $30.50 decreased by 50 cents leaves me with just $30, which is my initial charge or the starting amount. So before I ever take that car rental, I have to pay them $30 to just get the car. And then every mile added to that, I pay 10 more cents. So I can use all of that information to write my equation in slope-intercept form. So y will equal m, or slope times x. So 1/10 times x, plus that y-intercept or initial charge, which is 30. And there we have our equation that models this table. All right, thank you.